Dear students, very good afternoon. Today we are going to discuss about finding inverse Laplace transforms of some problems. So can you take down a problem? The first problem is find L inverse of 1 divided by s square plus a square into s square plus b square. And the second problem is find L inverse of s square divided by s square plus a square into s square plus b square. So these are two problems we are going to see today. Okay, dear students. Okay, so now how to solve this problem? Okay, how to solve this problem? So carefully listen the video. Okay, solution. So what they have given? They have given 1 by s square plus a square and 1 by s square plus b square. So the denominator is having multiple factors, whereas we are having a single numerator. Here also we are having multiple factors, that is we are having two factors. In the numerator we are having only single term, so we have to do a partial fraction. So how to do that? Let us take 1 by s square plus a square into s square plus b square equal to a s plus b divided by s square plus a square, then plus cs plus d divided by s square plus b square. And this is common here also. The same things are going to get repeated here also. The same things are going to repeat here also. So you have to copy the same steps. Okay, you have to copy the same steps for both the problems. Okay, you have to copy same steps for both the problems. So write how to solve this. Let now we can take the LCM, that is a s plus b into s square plus b square plus cs plus d into s square plus a square equal to 1. So here you will have s square plus a square into s square plus b square. Here also you will have s square plus a square into s square plus b square. Okay, now these two terms will get cancelled. Okay, now these two terms, both s square plus a square and s square plus a square, then s square plus b square and s square plus b square will get cancelled. Now we have to equate the coefficients of s cube, s square and s. Now we have to equate the coefficients of, okay, equating the coefficients of coefficients of s cube comma s square comma s and constant we have what will you have? See, on multiplying this as along with this s square, you will have s cube, am I right? So the coefficient of s cube will be a. The coefficient of s cube will be a, whereas here you will have cs plus cs into s square will give you s cube. So the coefficient of s cube will be c. So it is a plus c. Okay, in the right hand side there is no s cube term, so it will be 0. Okay, now coefficient of s square term. So the coefficient of s square term means you have to get a square term first. So when you will get a square, when you add when you combine these two, b and s square, and as well as d and s square, you will have d and s square, you will have s square terms. Okay, so the coefficient of s square will be b plus d. b plus d equal to 0. Okay, and now the coefficient of constants, the coefficient of s, so s will be obtained from b square and into as and a square into cs. So you will have this is s2. Okay, you will have s3. The coefficient of s3 will become a b square then plus c a square equal to 0, and you are having a constant term, and you are having a constant term, and you are having a constant. The constant is given by, see, the constant is given by b square. So b square, here you will have d a square plus d a square, that is in the right hand side you are having a constant, so that is equal to 1. Now we can combine all these equations. Okay, so s3 is having a plus c equal to 0, then s2 is having b plus d equal to 0. The coefficient of s3 gives ab square plus a square equal to 0, and the constants will give you bb square plus da square equal to 1. Now from the first equation, this is our first equation, this is our second equation, this is our third equation, and this is our fourth equation. So equation 1 implies a plus c equal to 0, which implies a equal to minus c, or you can say c equal to minus a. Okay, then equation 2 implies b equal to minus d, or d equal to minus b. Okay, so substitute these two things. What is this? This is equation number 5, and this is equation number 6. Substitute 5 and 6 in 3. Substitute 5 and 6 in 3. Substitute 5 and 6 in 3. You will have already we are having a b square plus c a square equal to 0. So a equal to c equal to minus a. So you will have a b square minus a square equal to 0, which implies a of b square minus a square, b of a square, b square minus a square equal to 0. Dear students, you have to know one thing here. This b square minus a square not equal to 0, because b not equal to a. They have not given such condition, but it is actually true. See, this is b, this is a. Whether they are equal? No, they are not equal. The constants itself are differ. So it is b, it is a. Since the constants itself are differing, we cannot say b square minus a square are equal to 0. So definitely it is not equal to 0. Then what will become 0? A equal to 0. A equal to 0. If a equal to 0, then from equation 5 you will have, from this equation you will have c equal to 0. Okay, c equal to 0. Okay, so now the equation 4 implies b square plus d a square equal to 1. That is our fourth equation. So on that we can write b square, then d can be written as minus b a square equal to 1, and it implies b of b square minus a square equal to 1. It implies b equal to 1 divided by b square minus a square. Okay, so this will therefore imply b equal to minus d, no? So b equal to minus d, so d equal to minus of b. Okay, it implies d equal to minus 1 divided by b square minus a square. Now you have substitute these values in 1 divided by a square minus a square into a square minus b square equal to what we have taken, a s plus b divided by what is it, a square minus a square plus c s plus d divided by a square minus b square. You have to substitute all the values here. Okay, so on substituting you will have, what is the value of a equal to 0 and and c equal to 0. So you will have b and d values alone. The value of b is 1 by b square minus a square. This is the value of b divided by a square minus a square plus the value of c becomes 0. So the value of d is minus 1 divided by b square minus a square divided by a square minus b square. So we can take the Laplace inverse Laplace transform, L inverse of 1 by a square minus a square into a square minus b square equal to, see, these are constants. What are constants? 1 divided by b square minus a square is constant, so we can take it outside. L inverse of 1 by a square minus a square minus 1 divided by a square minus b square. So we can take the partial fraction here. See, from this alone your steps will get changed. Okay, so here you have to take LCM. So 1 by b square minus a square, L inverse of a square minus b square minus a square, minus of minus will become plus a square whole divided by a square minus a square into a square minus b square, that is you will have 1 by b square minus a square, L inverse of a square minus b square divided by a square minus a square into a square minus b square, that is equal to 1 by b square minus a square, L inverse of a square divided by a square minus a square into, see, listen, here you will have one term is s minus a square and another term is s minus b square. So see, here we are having 1 by b square of this thing, 1 by s minus a square, but actually we need 1 by b square minus a square, L inverse of, we actually have to get a divided by a square minus a square, because this is having the formula. So we are multiplying the numerator by a and dividing by a, so it is 1 by a minus, in the same way multiplying dividing by b, so you will get b divided by a square minus b square. Okay, now by linear property we can write it as 1 by b square minus a square, L inverse of 1 by b square minus a square into 1 by b square minus a square into 1 by a, L inverse of a divided by a square minus a square, then minus 1 by b into b divided by a square minus b square. Okay, so now Now the answer is very very simple. 1 divided by b square minus a square into 1 by a sin at minus 1 by b sin bt. So this is the solution for the first problem. We are having a second problem now. We are having second problem, that is we are having s divided by s square minus a square and s square minus b square. So how to solve that? So you have to solve the problem from here onwards. From the beginning itself you have to solve. Okay, so how to solve that? That is what we are going to see now. So you have to solve from here itself. I have told you these steps are common. Okay, I have told you these steps are common, this positive fraction is common, but we are not going to apply it in the very beginning of the second problem. We are going to use it but in the middle. Okay, so now take the second problem. Okay, second problem is they have given L inverse of s square divided by s square plus a square into s square plus b square. So this is your second problem. Okay, so here you are having solution of one first problem. So now take okay, now see, listen, in the numerator we are having the function of s, in the denominator also we are having function of s, but in the denominator we are having multiple factors, that is the product of factors. In numerator we are having a single term s square. So I am going to take this as L inverse of s square. In the denominator I am having plus a square, no, so I am adding plus a square. Okay, but whenever I am adding something I have to subtract something, that is called without loss of generality. Without loss of generality means the balance of the equation should not be spoiled. Okay, we can add something if it is 0. See, listen, if x equal to y, the balance of equation should not be spoiled by adding or subtracting something. In the same way for multiplication division also. In the same way multiplication division also. Okay, so that is called without loss of generality. Okay, so I am adding s square plus a square. If I add s square plus a square means I have to subtract a square divided by s square plus a square into s square plus b square. Okay, now it can be written as L inverse of s square plus a square divided by s square plus a square into s square plus b square minus a square divided by s square plus a square into s square plus b square. Okay, now you got the point. Now we can cancel these two terms. So in order to make that we have produced such things. Okay, So that is the main reason. So here s square plus a square and s square plus a square will get cancelled. Okay, here both s square plus a square will get cancelled. So you will have L inverse of 1 divided by a square plus b square minus a square divided by a square plus a square into a square plus b square. Okay, so again it will become L by the property called linear property. You will have L inverse of 1 by a square plus b square in minus a square into L inverse of 1 divided by a square plus a square into a square plus b square. Okay, now you can see what is this. You can see what is this. What is this? This is our first problem. This is our first problem. So for this you have to do the positive fraction. If this question is asked in examination, from this step onwards you have to do the above positive fraction ideas. Okay, you have to do from this step. Okay, you have to do all these steps. Okay, all these steps, and you have to obtain the final result. 1 by b square minus a square. So now we can easily substitute the result. The answer is what is L inverse of s square plus b square? It is not possible to write directly, no. So we are writing L inverse of 1 by b into b square by s square plus b square, b divided by s square plus b square, then minus a square into, for this you are having the answer 1 divided by b square minus a square into 1 by a sin a t, 1 by a sin a t minus 1 by b sin bt, 1 by b sin bt. Okay, now here you will have 1 by b into sin bt minus a square divided by b square minus a square into 1 by a sin at, okay, sin at minus 1 by b sin bt. Dear students, you can simplify it further. That is, see, listen, here you are having here you are having 1 by b, that is sin bt by b, sin bt by b Okay, minus a square divided by b square minus a square. Here here you can take the LCM. So b sine at minus a sine bt divided by ab you will have. So it can be taken as sine bt by b minus this square and this will get cancelled. Okay, so you will get a b sine at minus a square sine bt divided by b into b square minus a square. So from this you can multiply this with b square minus a square, that is equal to b square minus a square sine bt divided by c minus ab sine at plus a square sine bt divided by b into b square minus a square, that is b square sine bt minus a square sine bt minus ab sine at plus a square sine bt whole divided by b into b square minus a square. Here this minus a square sine bt and plus a square sine bt will get cancelled. So you will have sine bt, b sine bt minus a sine at divided by a square divided by b square minus a square. Okay, or you can take negative commonly outside and both numerator and denominator you can write a sine at minus b sine bt whole divided by a square minus b square. So this will be the answer. This will be answer for L inverse of a square divided by a square plus a square into a square plus b square. A square plus b square. So I hope you all understood the problem and you have all enjoyed the problem. Thank you all once again for watching this video. I hope we shall meet on another video. Thank you all once again.